Whereas for full wave rectification, I use two diodes. The negative half cycle wouldn't be rectified. Diode D1 is reverse biased. Lots of impurities are added to the P and N sides of the diode, and the output is measured across the load resistor. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Continuing my discussion on the topic semiconductor physics, where I was concentrating on a process called as rectification. And in the previous session, we understood the performance or working of a PN junction diode as a half wave rectifier. So today in my session, we will understand the working of a junction diode as a full wave rectifier and a very special type of diode called as Zener diode. So we will start understanding something called as a full wave rectifier. Before I start, what is meant by rectification, students? We told it is the process of converting an input AC signal to an rectified output DC signal. What was a rectifier? It was a device like a junction diode which converted an AC signal into an rectified DC signal. And when we learnt half wave rectification, you saw there was only one diode which rectified only the positive half cycle from the input AC signal. The negative half cycle wouldn't be rectified, and therefore today we understand something called as full wave rectification. So we will understand the working of a junction diode as a full wave rectifier. And this is a very important 5-mark question that is asked again. 2020 paper, they have asked about half wave rectification. So all possibilities that you people may get full wave rectification as a question for 5 marks. Now, this is actually the circuit arrangement that is done to understand the phenomenon of full wave rectification. So now is circuit arrangement now full wave rectification goskara ಬಳಸ್ಕೊಳ್ತೀವಿ. Now here is a transformer which I call as center tap transformer. So I am using a transformer which is called as a center tap transformer. Again, this is the input AC signal that has to be rectified, which is fed to the transformer. Again, I have a load resistor RL across which the output is measured. But the only difference here is I am using two diodes, two junction diodes. So D1 and D2 are the two junction diodes which are used for rectification. So understand, students, the circuit arrangement that is done for full wave rectification consists of a center tap transformer. The input AC that has to be rectified is fed to the transformer, and the output is measured across the load resistor, and we are using two diodes D1 and D2 for full wave rectification. Two semiconductor diodes D1 and D2 for full wave rectification. Now, to understand the working of the full wave rectifier, concentrate thoroughly. During the positive half cycle, so I consider the positive half cycle. During the positive half cycle of the input AC, the point A is positive with respect to the point B, which means to say, again, this is the input AC, positive half cycle and negative half cycle. As the positive half cycle is reaching the transformer, the end A becomes positive and the end B becomes negative, because of which the diode D1 is forward biased and the diode D2 is reverse biased. ನೋಡಿ ಎಷ್ಟು ಬ್ಯೂಟಿಫುಲ್ ಆಗಿದೆ. during the positive half cycle, the diode D1 is forward biased and the diode D2 is reverse biased. Now, because of which the diode D1 starts conducting, hence the current I1 flows through the load resistor. So very beautiful to understand here. During the positive half cycle of the input AC, when it is fed to the transformer, the point A becomes positive when concerned to the point B. This makes the diode D1 forward biased and the diode D2 reverse biased. D1 ಪಾಸಿಟಿವ್ ಆಗಿರೋದ್ರಿಂದ ಕಂಡಕ್ಟ್ ಮಾಡುತ್ತೆ, D2 ರಿವರ್ಸ್ಡ್ ಬಯಾಸ್ಡ್ ಆಗಿರೋದ್ರಿಂದ ಕಂಡಕ್ಟ್ ಮಾಡೋದಿಲ್ಲ. Therefore, a current I1 is getting flown through the load resistor RL. So, if I observe the output here, the positive half cycle is getting rectified. Now, what happens to the negative half cycle? During the negative half cycle of the AC, negative half cycle of the input AC voltage. Now this is the other way, which means to say point A is negative with respect to point B, which means now during the negative half cycle, when we have the negative half cycle, B becomes positive and A becomes negative. This is during the negative half cycle. So that the diode D1 is reverse biased and D2 becomes forward biased. ನೋಡಿ ಎಷ್ಟು ಬ್ಯೂಟಿಫುಲ್ ಆಗಿ ವರ್ಕ್ ಆಗ್ತಿದೆ. During the negative half cycle, diode D1 is reverse biased and diode D2 is forward biased, which means to say now D2 starts conducting and D1 is not conducting now. Hence, a current I2 flows through the load resistor. Therefore, here, to understand now, during the negative half cycle, when the negative half cycle reaches the transformer, the point B becomes negative with respect to the point A, which means to say the diode D2 is forward biased and the diode D1 is reverse biased. Since D2 is now conducting, why forward biased? Current I2 flows through the load resistor. And therefore we say here even the negative half cycle is getting rectified. Therefore, it is called full wave rectification. I am using two diodes to rectify full wave, and hence, if you can see here, the output waveform. So this is the input waveform. Positive half cycle, negative half cycle, positive half cycle, negative half cycle. Here you observe, positive half cycle is rectified, negative half cycle is rectified. Positive half cycle is rectified, negative half cycle is rectified. Therefore, by using two diodes, both the cycles are getting rectified, and therefore we call this full wave rectification. So, dear students, very clearly we have understood the differences between full wave rectification and half wave rectification. Where for half wave rectification, I used only one single diode and only positive half cycle got rectified. Whereas for full wave rectification, I use two diodes and both the half cycles, the positive half cycle as well as the negative half cycle, gets rectified. Now, we will study a very unique diode by the name Zener diode. ಈ diode ನ ಏನ್ ಕರೀತಾರೆ? Zener diode ಅಂತ ಕೇಳ್ತಾರೆ. And in the exam, this is again asked as a 3-mark question. Features of Zener diode. So this is the symbol of Zener diode. ವ್ಯತ್ಯಾಸ ನೋಡಿ, ಬೇರೆ ಯಾವುದೇ ಡಯೋಡ್ ಆಗಿದ್ರೆ ಜಂಕ್ಷನ್ ಡಯೋಡ್ ಅಂತ ಏನ್ ಕರಿತಿದ್ವಿ, this would be the symbol PN junction. But if you observe here, the N junction is represented by a Z-like symbol just to identify that this is a Zener diode. N junction na straight line al indicate madidre, it is a PN junction diode. If it is represented by Z, it is Zener diode. And as you can see, the Zener diode was designed by the scientist C. Zener. So C. Zener was the scientist who designed the Zener diode. It is a diode which is designed to operate under reverse breakdown voltage. Very important. This is a diode, a Zener diode, which will always function, which will always operate in the reverse biased mode or reverse breakdown voltage. here the P and N junctions are heavily doped. Lots of impurities are added. High doping is done to the P and N sides of the junction. Because of this doping, because of this impurities added, the width of the depletion region is very, very thin, around micrometers. ಏನು ಮಾಡ್ತಿದ್ದಾರೆ? P and N junctions heavily doped. They are added heavily with impurities so that the depletion region formed is very, very thin potential barrier around 10 power minus 6 meter. And the electric field of the junction is very high even for reverse bias voltage. So if you are studying the characteristics of a Zener diode, the symbol or representation of Zener diode is pretty unique. PN junction represented by a straight line for the N junction. Here it is Z for the N junction. Typically designed by the scientist Zener. Mode of operation for a Zener diode, reverse biased current or reverse breakdown voltage. Heavy amount of doping is done. Lots of impurities are added to the P and N sides of the diode. The reason being the width, the depletion region should be very, very thin, around 10 power minus 6 meter. And finally, the electric field is very high even for small reverse biased voltage. So this is the IV characteristics. Current voltage characteristics for a Zener diode. Now we have current in milliamps, voltage, and you can clearly see conduction is happening only in the reverse biased mode. From the graph, it is observed that there is a large change in current, an exponential change, huge change in current when the reverse bias voltage reaches something called as Zener breakdown voltage. When this reverse bias voltage is attaining something called VZ, Zener voltage, there is a large change in current. See, until here there is some consistency, but once that Zener voltage is seen, there is an exponential change in current. And this can be observed by a small change in the reverse bias voltage, that is Zener voltage. So this reverse bias voltage called Zener voltage remains constant for a wide range of application. So here you have to understand the primary importance of Zener diode is it functions only under reverse bias conditions. See, for particular reverse bias voltage, yes, it is somewhere saturated. The moment Zener voltage is attained, there is an avalanche breakdown, sudden change, and this is the characteristic of Zener diode. So in today's session, students, we understood what is full wave rectification, function of junction diode as a full wave rectifier, what is a Zener diode, its representation, and finally the characteristics of a Zener diode. In my next session, I come up with more interesting concepts. Until then, have a nice time. Thank you.